In this example, we're going to take a look at the linear regression line, an example from our text. So here we'll take a look at the depth scuba diver dives and the maximum dive time related to that depth. So to do that, we're going to need to copy this data into our spreadsheets. Highlight, oops, I missed one. There we go. Control C to copy. In your spreadsheet, we're going to paste that in. So here I have the X column and the Y column. It's always a good idea to graph the data to see if it looks reasonably linear. Excuse me. And choose a scatter plot. Well, there's a little bit of a curve to it. We're going to say it's linear enough. One way to get some more details is to customize the chart by going to the series section and adding a trend line. The default is a linear trend line. There are other options. I want to label with the equation, and I want to also show r squared. Alright, so it gives me the slope here and the y-intercept, and that is incorrect because it is messing up the horizontal axis. So we don't want to treat the text as labels. We want to treat, labels as text. We want to treat them as numbers. That looks more like it. Alright. Alright, so I have my slope times x plus my y-intercept, and I have r squared there. So there's another way to get those values I want to show you here. So there's formulas for the slope of a regression equation, the y-intercept, r, and r squared. So r is known as the correlation coefficient, and r squared is the coefficient of variation, and the coefficient of determination. There we go. And it predicts how much changes in the independent variable x predict changes in the dependent variable. So it's the percent we can use to predict. And here it's 92.7%. So we can predict with 92.93% assurance any variation of the independent variable explains what's happening with the dependent variable, the y. So that's pretty tight. So slope, the formula is just slope. And they want you to get the y values first and then the x values second. So that's important to get the order right, otherwise you get the inverse and not necessarily the right answer. Intercept is just intercept. There we go, intercept. And again, that one y, comma, x. And the numbers we get here match the numbers that the graph predicted. The correlation coefficient is the Pearson product moment correlation coefficient, and that similarly wants the y, and then the x. And the negative there tells us that this is decreasing slope. And then the coefficient of determination is RSQ. And then again wants the y, comma, x. And just to double check the relationship between the two of these, if you take this value of r and square it, so if I take my r value and raise it to the second power, then I get the coefficient of determination. Similarly, if I had the coefficient of determination, like is given here on the chart, then I could take the SQRT, the square root of it. And what I'm lacking is the sign, the direction, but I can see that from the slope. It's a negative slope that goes downhill. All right, so there's the numbers that I need to make these come out. Now, keep in mind when you calculate a regression equation, it's not going to exactly predict the data values. What it's going to do is kind of even them out in a way that reduces the amount of error. And error is defined as the distance between the point and the y value on the line. So let's clean this up a little bit and check that out. So I'm going to model these values by using my equation. So what I want to do is I want to take the slope times my x value, add on my intercept. In order to fill that down, I need to fix a couple of things. So the slope is fixed in row 2. The x value should vary, no dollar sign, and the y-intercept is fixed in row 2, so we move the dollar sign. All right, once I fix that, I can then fill this down and then go over what these numbers mean. Let's clean them up a little bit more. That's my place. So again, the usual idea is to have one more decimal place. Actually, I don't need one. So let's reduce the number of decimal places to 1 there. Except for these guys, probably not. Decimal places. All right, that's better. We'll go with that. So here, the model predicts that for a depth of 50 feet, the dive time should be 71. I believe that's in minutes. 71 minutes. So you can see here the line predicts 71 versus the data set 80. At a depth of 60, the actual dive time from the data was 55 minutes, but our y value from the model predicts 60. You can see that on the graph here. So I'm over predicting some places and under predicting in others. So for example, at a depth of 100, the recorded time was 22, but my model says 15.8. You can see the y value of the model is a little lower than the actual data. All right, here we have a regression equation. We can find that equation in 2 different ways, either by having the chart display the regression equation, or we can calculate through formulas the slope, the y-intercept, correlation coefficient, and the coefficient of determination. Thanks, and do good math.